Let me start with a gentle provocation. What if running, that symbol of fitness, discipline, and grit, is not the gold standard we've been sold, but simply one tool among many, and not always the wisest one for the human body? For decades, we have treated running as a moral achievement, as if sweat and suffering automatically translate into health. Yet biology has never cared about our cultural narratives. The body only responds to signals, and it judges those signals not by intensity alone, but by relevance, balance, and sustainability. When scientists study long-term health outcomes, they do not see a simple reward for repetition. They see trade-offs, adaptations, and sometimes quiet costs accumulating beneath the surface. From an evolutionary perspective, humans did not wake up each morning to run in straight lines on hard ground for miles at a time. We moved in bursts, we carried loads, we climbed, squatted, balanced, and rested. Our tissues evolved to tolerate variation, not constant impact. Bones strengthen when loaded thoughtfully, but cartilage has no blood supply and recovers slowly. Tendons store and release energy, but they fray when asked to repeat the same pattern endlessly. Running, especially as a primary form of exercise, can sharpen the cardiovascular system while simultaneously neglecting the structural integrity that makes movement possible in the first place. There's also the metabolic illusion. Running feels productive because it burns calories visibly and immediately, yet the body is not a simple furnace. Muscle mass, not mileage, determines how efficiently we regulate blood sugar, hormones, and inflammation over time. Slow, controlled resistance movements stimulate muscle fibers that running barely touches, particularly those responsible for stability and posture. These fibers send signals to the liver, the pancreas, and even the brain, shaping how the body responds to stress and aging. In this sense, strength-based movement is not about aesthetics or power. It is about cellular communication, about teaching the body how to manage energy long after the workout ends. Then there's the question of where versus wisdom. High-impact repetition elevates heart rate, but also amplifies joint stress, especially as tissue hydration and recovery capacity decline with age. Many people interpret pain as weakness rather than information, pushing through discomfort until the body adapts not by becoming stronger, but by becoming guarded. Movement becomes narrower, breath becomes shallow, and posture subtly collapses. What looks like dedication from the outside can sometimes be a quiet negotiation with injury on the inside. Health, when viewed scientifically and compassionately, is not about how much stress we can survive, but how intelligently we apply it. Movements that challenge strength, coordination, and awareness simultaneously produce broader adaptations with fewer sacrifices. They respect the fact that the human body is not a single system, but a living conversation between muscles, nerves, joints, and breath, a conversation that thrives on nuance, patience, and signals that say not just move faster, but move better, move with intention, move in ways that allow the body to remain curious rather than defensive, capable rather than exhausted, responsive rather than merely enduring, still open to growth rather than locked into survival mode, still listening for balance rather than chasing distance, still learning how to move as a whole rather than breaking itself into parts, still guided by biology rather than habit, still grounded in the quiet intelligence of how the body was always meant to move and adapt within the rhythms of life and time. A second movement principle that quietly outperforms running is slow, deliberate strength, the kind that asks the body to work deeply rather than quickly. When a muscle contracts under control, especially against gravity or load, it does far more than move a limb. It sends biochemical messages throughout the body, signaling adaptation, resilience, and preservation. Modern science now recognizes skeletal muscle as an endocrine organ, one that releases myokines influencing inflammation, immune function, and even brain health. In contrast to the fleeting metabolic spike of running, slow strength creates a longer echo inside the body, one that continues to shape physiology hours and even days after the movement has stopped. From a biological standpoint, strength is survival memory. Our ancestors lifted, carried, pushed, and held objects as part of daily life, and the genome still expects these signals. When muscles experience sustained tension, bone cells are stimulated to maintain density, connective tissues thicken and organize, and joints learn stability rather than collapse. Running largely bypasses this process. It relies heavily on elastic rebound, allowing momentum to do much of the work, which is efficient for speed but limited for structural development. Strength movements, especially those performed slowly, remove momentum entirely, forcing tissues to adapt honestly to the load they bear. There is also a profound metabolic distinction. Muscle tissue acts as a reservoir for glucose, pulling sugar out of the bloodstream and storing it safely. As muscle mass and quality improve, insulin sensitivity improves with it, reducing the strain on the pancreas and lowering the risk of metabolic disease. Running can help manage blood sugar in the short term, but it does little to expand this storage capacity. Strength, by contrast, changes the size and efficiency of the container itself. It alters baseline metabolism rather than temporarily distracting it. Equally important is the nervous system's role. Slow strength requires focus, coordination, and internal awareness. Motor units are recruited intentionally, not reflexively, reinforcing neural pathways that improve posture and joint control. This kind of movement teaches the brain how to distribute force evenly, protecting vulnerable areas like the knees, hips, and lower back. Over time, the body learns confidence under load. Movements become quieter, more economical, less reactive. This neurological refinement is absent in repetitive impact activities, where the brain often disengages and allows patterning to run on autopilot. There's a psychological layer as well. Slow strength cultivates patience. It removes the distraction of speed and forces confrontation with effort itself. Breathing deepens, attention sharpens, and the body is experienced from the inside rather than observed from the outside. This internal dialogue reduces stress hormones and increases the sense of agency over one's own physical state. Instead of chasing distance or pace, the individual learns to feel alignment, tension, and release. Perhaps most importantly, slow strength respects aging rather than fighting it. As recovery capacity changes, this form of movement remains scalable, precise, and forgiving while still profoundly effective. It builds bodies that are not just fit, but usable, capable of lifting groceries, rising from the floor, stabilizing a stumble, and carrying life's demands without protest, without urgency, without the need to outrun time, continuing to adapt quietly as long as the signal remains clear and intentional. The third movement principle that often surpasses running in long-term value is balance and coordination, the quiet skills that keep the body organized in space. These movements rarely look impressive, yet they determine whether strength and endurance can be expressed safely at all. From a scientific perspective, balance is not a single ability, but a collaboration between the inner ear, the eyes, the sensory receptors in the skin, and the nervous system's map of the body. Every time a person stands on one leg, shifts weight slowly, or controls a step in multiple directions, the brain is forced to update that map, sharpening its understanding of where the body begins and ends. Running simplifies this process. It locks the body into a repetitive forward pattern, reducing the need for lateral control or rotational awareness. While the heart benefits, the nervous system receives limited information. Balance-based movements do the opposite. They flood the brain with data. Small stabilizing muscles around the ankles, knees, hips, and spine activate reflexively, creating a web of protection that cannot be developed through straight-line motion. These muscles are not designed for speed or power. They exist for precision, and precision is what prevents injury long before strength or endurance ever matter. As people age, the cost of neglecting balance becomes increasingly visible. Falls are not caused by weak hearts, but by delayed reactions, poor joint awareness, and reduced confidence in movement. Balance exercises train reaction time and decision-making under mild stress, teaching the nervous system how to correct itself before gravity wins. This is not about athleticism, it is about survival. Studies consistently show that improved balance reduces fall risk, maintains independence, and preserves dignity, outcomes that no amount of running mileage can guarantee. There is also a cognitive dimension. Coordinated movement stimulates areas of the brain involved in attention, memory, and executive function. When the body must adjust to subtle changes in position, the brain cannot drift. It must remain present. This engagement strengthens neural networks that support learning and adaptability. Running, especially at steady paces, often allows the mind to disengage, which can be calming, but it does little to challenge cognitive motor integration. Balance asks the brain to think and feel simultaneously, reinforcing the connection between intention and action. Emotionally, balance builds trust. Each successful correction, each quiet recovery from instability, reinforces the belief that the body can handle uncertainty. This confidence carries into daily life, changing how people move through crowded spaces, uneven terrain, and unexpected obstacles. Fear decreases not because risk disappears, but because capability increases. The nervous system relaxes when it knows it can respond. Balance training also encourages humility and patience. Progress is subtle, sometimes invisible, yet deeply transformative. Movements slow down. Breathing becomes more natural. The body stops bracing and starts listening. Instead of overpowering the environment, the individual learns to negotiate with it, adapting moment by moment, staying upright not through force, but through awareness, sensitivity, and timing, refining the internal dialogue that allows strength and endurance to express themselves without conflict, without strain, without the constant need to recover from excess. Remaining responsive rather than rigid, present rather than hurried, steady in motion and in stillness, alike the fourth movement. Principle that often proves more restorative than running is low-impact mobility, the kind that invites joints to explore their full, natural ranges without force or urgency. From a biological standpoint, movement is nourishment. Joints do not receive blood directly. They depend on motion to circulate synovial fluid, delivering nutrients and removing waste. When movement is repetitive and narrow, as it often is in running, certain tissues are bathed in stimulation while others are left underfed. Over time, this imbalance stiffens the body not because it is aging, but because it is underinformed. Mobility-focused exercises reintroduce variety, rotating the spine, opening the hips, reaching overhead, and moving diagonally stimulates sensory receptors embedded in connective tissue. Fascia, once thought to be inert wrapping, is now understood as a living, responsive network rich with nerves. It adapts not to force, but to slow, sustained tension and release. When mobility movements are performed gently and consistently, fascia reorganizes itself, improving elasticity and reducing pain signals that were never structural damage, but protective responses to unfamiliar or neglected ranges. Pain science adds another layer of understanding. Many chronic aches are not the result of tissue failure, but of nervous system vigilance. The brain restricts movement when it perceives threat, even in the absence of injury. Low-impact mobility communicates safety. Slow, controlled exploration tells the nervous system that range is allowed, that joints are stable, that motion does not equal danger. As this message repeats, protective tension dissolves. Muscles lengthen not because they're stretched, but because they no longer need to guard. There's also a metabolic subtlety here. Gentle mobility improves circulation without triggering stress hormones. Unlike high-impact exercise, which can elevate cortisol when recovery is insufficient, mobility movements often downregulate the stress response. Heart rate increases modestly, breathing deepens, and the parasympathetic nervous system engages. This state supports digestion, tissue repair, and immune function, aspects of health that are easily overshadowed by the pursuit of cardiovascular output alone. Mobility work also restores movement options. When joints regain access to their full ranges, strength and endurance become safer and more efficient. A hip that rotates freely reduces strain on the knee. A spine that flexes and extends distributes load more evenly. Running, by itself, rarely corrects these restrictions and often reinforces them. Mobility acts as a reset, reminding the body of possibilities it quietly forgot. On a more human level, mobility encourages curiosity rather than conquest. There's no finish line, no pace to beat, no distance to log. The focus shifts inward. Sensation replaces measurement. The body becomes a landscape to explore rather than an object to discipline. This shift alters the relationship with movement itself, transforming exercise from an obligation into a form of care, a daily conversation with joints and tissues that responds best to patience, attentiveness, and respect, allowing the body to remain supple not just in muscle and joint, but in attitude, in its willingness to move freely, adapt gently, and stay open to motion across the long arc of life. The fifth movement principle that often exceeds running in its impact is integrated, breath-led effort, where movement and respiration are inseparable rather than competing demands. From a physiological perspective, the breath is not merely a response to exercise. It is a regulator of internal state. How we breathe determines heart rhythm, blood chemistry, and nervous system tone. When movement is paired with controlled breathing, the body learns efficiency instead of urgency. Oxygen delivery improves not because the heart works harder, but because cells become better at using what they receive. Exercises that blend sustained effort with steady breath, such as controlled carries, slow climbs, or prolonged holds, create a unique cardiovascular stimulus. The heart rate rises, yet remains within a range that favors aerobic metabolism. Mitochondria, the energy-producing structures inside cells, respond by increasing both number and function. This adaptation supports endurance at the cellular level, reducing fatigue and improving recovery. Running can drive similar adaptations, but often at the cost of elevated stress hormones, especially when performed frequently without adequate rest. Breath-led movement also reshapes the nervous system. Slow exhalations stimulate the vagus nerve, which lowers heart rate and signals safety. When effort occurs in this state, the brain learns that challenge does not require panic. This recalibration has profound effects beyond exercise. Stress resilience improves. Blood pressure stabilizes. Inflammation decreases. The body becomes less reactive to physical and emotional strain alike. Running, particularly when intense, can reinforce a fight-or-flight pattern that feels productive but leaves the nervous system chronically alert. There is a biomechanical benefit as well. When breathing is coordinated with movement, posture improves automatically. The diaphragm works in harmony with the deep abdominal and spinal muscles, creating internal stability. This reduces unnecessary tension in the neck, shoulders, and lower back. Movement becomes smoother, more economical, less prone to compensation. Many injuries attributed to weakness are actually failures of breath and timing, issues that running rarely addresses directly. On a psychological level, breath-integrated exercise fosters presence. Counting steps or miles fades into the background. Attention settles on sensation, rhythm, and control. This meditative quality alters the perception of effort. Discomfort becomes information rather than an enemy. The individual learns to modulate intensity instead of escaping it, to stay with challenge long enough for adaptation to occur without tipping into exhaustion. Perhaps most compelling is how this approach reframes fitness as regulation rather than domination. The goal is not to push the body beyond its limits, but to expand those limits by teaching the system how to remain calm under load. Over time, this creates a body that recovers quickly, adapts gracefully, and sustains energy across the day rather than spending it all at once. Movement becomes a tool for balance, not depletion, a way to align breath, heart, and muscle into a single rhythm that supports vitality without violence, effort without strain, and longevity without the constant need to outrun decline. continuing to build capacity quietly, steadily, and with an intelligence that honors the body's deeper design.